Hello, this is the Engineering Admissions Assessment 2022, Section 1. It's the first video, so I'll do Part A, the Maths and Physics questions, 20 multiple choice. And a long way down to question 1. Which one of the following is the simplification of this? Okay, so we've got, for y's, we've got a 1, we've got a minus 6. So we're going to have over, I'll put the pen on, over y to the 5. We're going to have a 3 squared. We're going to have an x because we're squaring the square root, and we'll have a z squared, which is, where are we, e? Okay. Question 2. Constant current in a conducting wire, charge of 20 coulombs passes through the wire in 1.5 minutes. We've got a bit of straight wire and a uniform magnetic field. Okay. Perpendicular, there's the field strength. What's the magnitude of the force? So we want B, which is 0.15, times I, which is 20 coulombs over 90 seconds, times L, which is 0.18. So we've got 1.5 lots of 2 over 9 times, well, let's make that an 18, and then have a 10 to the minus 3 on the end of all of that. Cancel those to give a 2, so we'll have 6 times 10 to the minus 3, which is A. Okay. Find a complete set of values of x that satisfy that inequality. All right, so it's just linear. So I multiply by 4 all the way through, and so I've got 15 minus 3x minus 12 plus 2x minus 4x is less than 0. So that's 3 for that and that. And then I've got minus 5x is less than 0. So I need x to be greater than 3 over 5. D. Usual warmer upper ones. 2 identical resistors are connected in parallel to a 6-volt battery. They dissipate that amount of power. One of the resistors is removed and connected to a 12-volt battery. How much charge passes through this resistor in 6 minutes? Okay, so we want the current when we move it somewhere else. So we want to get the resistance here. So we've got our V squared over R is going to be, so we've got 2 resistors. So that would be a 0.15 divided by 2. And V squared is 36. So our R is going to be 2 times 36 over 0.15. And then we've got a 12-volt battery. So we want to do 12 divided by all of this thing. So 2 times 36. And then we'll put a 0.15 at the top. And then we need to multiply that by 6 minutes. So 6 by 60. Right, so we've got quite a lot of numbers we want to mess around with here. So we've got a 6 there, a 6 there, and a 36 there. So we're just multiplying these two things together by the look of it. So 1.5 sixes is 9, which is G. Okay. Rob keeps a record of what he earns each day. On Monday, he gets 50% less than on Sunday. Tuesday, 20% more. Okay, well, yeah, get the idea. Wednesday, so on Wednesday, he's got 84. So that's 30% less than what he had on Tuesday. So for Tuesday, we're going to want to divide by 0.7. And then on Tuesday, he's got 20% more than he had on Monday. So we can divide through by the 1.2. And then on Monday, he had 50% less than he earned on Sunday. So essentially, we're just going to be doubling this all in all by the time we get to the end of it. So, okay, we've got 84 divided by 7. We can put another, we put a 10 up there. So that's going to be 12. And then we're going to have 12 divided by 1.2 is 10, multiplied by 20 is 200. So D. At least they gave us some nice numbers there. Okay. C. Ultrasound is used to find a crack in the block. Yep. So we zap it down. Don't need to read all that. We know what they're asking, really. Speed of the ultrasound is that. They've given us this graph. What's the distance between the bottom of the block and the crack? Right, okay, so we've got one coming back from the crack. They've done these sort of questions so many times. That's coming back from the bottom. So we're going, what is that? That's 0.08, is it? Yeah, 0.08 times 10 to the minus 3. So that is 2 times the distance divided by that 5,000. So the distance then is going to be 0.4, 0.04, I mean, and then multiply by the 5,000, and all those zeros are going to cancel. So we're just doing 5 times that. So D is going to be 0.2 meters, which is A. Okay. 7. Which of the following is a simplification of this? Okay, oh, we put a divide in the middle as well. So let's flip these while I'm going through it. So that's going to be an x minus 3, x plus 2. The top one, which I'm putting on the bottom, is going to be an x plus 4, x minus 3. Here we've got difference of two squares on the bottom, so 5x minus 3, 5x plus 3. So they're bound to want that to cancel with something on the top. So it makes it easier to factorise, doesn't it? We're going to have a minus 4 there, are we, and a plus 3. That will work. So what's cancelling? That cancels with that. That cancels with that. And we're left with x minus 4, x plus 2 on the top, and 5x minus 3, x plus 4 on the bottom, so C. Power supplied to an electric motor is that it's got efficiency of 60%, it's on for half an hour. How much energy is wasted? Right, okay, so we're losing 40%. Half an hour of this, so we've got 60 times 30, that's our number of seconds. Then we need to multiply by, well, 0.8 kilowatts, so 800. So that's quite a lot all in all. So how are we going to do this? We've got 1, 2, 3, 4, minus 1, 0. So we've got 3 zeros at the bottom, at the end even. So it's going to be G or H. And then we've got 32 times 18. So that's going to be 640 minus 64, so 576. So G. Rectangle PQRS, length that, width that. We add 3 centimeters to length and width, and we get a new area of that. What's the ratio of PQ to PS? Okay, so we've got x plus 4 times x, it's not x, it's 2x minus 1 plus 3, so plus 2 is equal to 360. Okay, so that is 2x squared plus 10x plus 8, and then we're going to have to take off all of that. Actually, I could halve it all, couldn't I? So let's do it in steps. I don't want to make a stupid mistake. So x squared plus 5x, so it'd be plus 4 minus 180, so minus 176 is equal to 0. So 176, you want to get something with a 5 difference, but that is 16 times 11, so that works, doesn't it? So we couldn't, we'd have x is minus 16 or x is plus 11. So x is 11. So what have I got then? So I've got 12 to 21. I can get rid of 3s, 4 to 7. 4 to 7, B. Okay. Question 10. We got a graph showing PD against current for a filament lamp and a resistor. Lamp and resistor connected in parallel to each other in a 6-volt power supply. The current in the lamp is, so they're in parallel. We want the current in the lamp, so okay, well, I'll just be reading it off the graph. Second circuit, the lamp and the resistor are now in series. Same power supply, current is that, and the PD. All right, this is easy enough, isn't it? We're just reading it off the graph twice. So when we got 6 volts, we want to get the current in the lamp, which is going to be the curved one. So that's here. So we've got 0.35 amps. And then we've got a current of 0.18. And we want the PD. Okay, so 0.18 is what here? So what's that, 1.8? So 0.35, 1.8. No, it's obviously not 1.8. What have I misread on this then? Do we want the second one? The lamp and the resistor are connected in series Potential difference across the lamp is recorded. What am I getting the wrong? 0.1 amps, 0.18 amps. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, and that is. Oh yeah, I'm just reading the. Yeah, I'm reading the scale wrong on the way up here. That is a 6, not an 8. Yeah, so 0.35, 1.6. So D. Okay. PQRS is a trapezium as shown. Tan RSQ. Okay, that angle. Right. Okay, it's 5/8. What is the length of PS? Right, so if that is 5/8, opposite over adjacent is 5/8. So this must be 25. So we want what? PS. And we've got 30 here. So we know that that is 40. So PS is, well, PS minus that 25. And then we want to do opposite over adjacent. So 40 divided by PS minus 25 is going to be 1/√3. So PS is going to be 40√3 plus 25. Is that on here? Yes, it's G. Okay. 12. Transverse wave speed 500 meters per second. We've got the horizontal distance between the 2 points P and Q of the wave is 4 meters. So that's that, what, 2 wavelengths. So we've got wavelength is 2 meters. Time 0 milliseconds. Point X on the string is at maximum displacement. So this is T is 0 up here. What's the displacement of point X at time 7 milliseconds? Right, okay, so we want to get our time period then on all of this, don't we? So the frequency is 250 hertz. Our time period is then going to be, well, we want to do 1/that, so 4 milliseconds. So we've done 1 3/4 cycles after 7 milliseconds. So 1 takes us back where we want to be, well, back to the start, and then we go down there, back up there for 3/4. So that's going to put us at equilibrium. Displacement of X, so it's going to be at 0, which is C. 13. Solid cylinder, radius r, height h, cube, side length that. Total surface area of the cylinder is 4 times the surface area of the cube. Okay, so we've got 4 lots of 6 lots of 9r squared. So that's 4 lots of the area of the cube is the same as the solid cylinder, and then we have to get h as the subject, right? So the cylinder is going to be 2 lots of pi r squared plus a 2 pi r h all in all, and we need to make h the subject of all of this. Okay, let's get rid of some 2's. So we've got 12 times 9, which is 108, times, oh, I can get rid of some r's as well, actually. R, and R times r. And then that is equal to pi r plus h. So divide by the pi, take off the r. 108r over pi minus r. So I just factorise the r, so it's G. Okay. 14. Piece of metal of mass 50 grams, thermal equilibrium in a hot liquid, temperature T. Smooth and liquid, put in 100 grams of water, 20 degrees C, and it reaches equilibrium at 26. What's the temperature of a hot liquid? Okay, right, so we're doing, what's the increase in the water then? The water's gone up 6 degrees. There's 100, I'll just do it in 100 grams because the grams will cancel on either side, times 4200, and that's going to be the delta T that we've had for the hot metal times the 50, so that's where the grams cancel, and then the 350. Right, God, there's a lot here, isn't there? So, well, we can get rid of that and make a 2, so let's make that a 12. Get rid of that and that. So delta T is going to be 12 times 420 over 35. And, oh, right, there we go. 420 over 35 is 12, isn't it? So we've got 144, and that's delta T. So we need to add on 26 to get 170, which is D. Those ones are a bit quicker than when they have the, you know, something's melting as well. We didn't have to worry about any latent heat in that one, so makes it a bit easier. Okay, we got that equation. They want to make y the subject. Okay, right, so we got x minus 2xy cubed is 5 minus 10y cubed minus 2y cubed minus 1. So we've got x is equal to 4. We've got minus 12y cubed. And then we, oh yeah, I need to, yeah, okay, no, I could do this the other way around, yeah. So minus 12, yeah, it's going to be a bit of a pain anyway. Minus 12y cubed, and then plus 2xy cubed. I'm just wondering which way round to factorise. What they put the x as positive in the thing. So anyway, so I've got an x minus 4 is equal to y cubed 2x minus 12. So x minus 4, 2x minus 12, and then cube root it. Oh, which is where my pen is next to, which makes it easier than scanning down all the answers. Comes out as being E. 16. Bar magnet is placed at position X close to one end of a coil on the axis of the coil as shown. Graph shows that the velocity of the magnet varies as it is moved rapidly at position Y and then back to position X. Okay. Magnetic field of the bar magnet still affects the coil when the magnet is at position Y, which graph represents how the induced voltage in the coil changes as the magnet moves. Right, well, it's going to have to be opposite as we're going out and back. So they're going to be, we're going to have a sort of mirror image of each other. So it's not going to be B. Plus they said the magnetic field of the bar still affects the coil at position Y. I suppose you're going to get an instantaneous, it's going to go through at 0 though, isn't it? But yeah, so we are going to cross the x-axis, but it's not going to be B because we have to have a positive and a negative, because we're going to get a different voltage depending on direction of the voltage, depending on which direction we're moving in. So it's not going to be those. It's got to be dropping off with distance from X to Y. So that only leaves D, because A isn't dropping off with distance, and F is going the wrong way. It's not going to increase as we're moving away. So it's going to have to be D. Don't really have any choice. 17. 3 different numbers are chosen at random from those. What is the probability that 3 numbers form the 3 sides of a right-angled triangle? So square one, add square of the other, and then, all right, when we square them all, we just get straight numbers. So we need options that just add up. So we could have 1, 2, 3, square, yeah, because you'd get, these are the squares, add those two, you get that one. Okay, so we can have 1, 2, 3, 1, 3, 4, 1, 4, 5, 2, 3, 5. That's going to be it, isn't it? We can't do any others. Just going to be those 4. So how many ways can we pick these? Well, we're leaving 2 out, essentially. So if we're leaving 2 out, we're going to have 4 plus 3 plus 2 plus 1 ways of doing that. So we're going to have 10, 4 over 10, 2 over 5, E. Okay, 17. So 18. Small slider of mass 30 grams that rests at the bottom of a frictionless slope. Okay. Spring is compressed by 5 centimeters. Slider remains in contact. Yeah, it's released and it goes up 20 centimeters. Right, so we're now replacing the slider with a mass of 20 grams. So that's gone down from 30 to 20. We compress it by more. And what do we get as a new height? Okay, so if we're compressing, so 3 times compression is going to lead to 9 times energy. And we're reducing the mass down to 2/3 of it. So we're going to end up getting, well, it's going to go further up, isn't it? It's going to go 3 over 2 times. So we're going to have 3 over 2 times 9. So we've got 27 over 2 times the height. And what was the height? Where did it go? I can't even see. Oh, we go 20 centimeters. So times 20. So we're going to have 10 centimeters times 27. Okay, so 2.7 meters, 270 centimeters. F. 19. The 0.15 is translated to that 0.32 with two successive translations. What are P plus Q? Okay, so we've got 3P plus Q is going to be, we've got a change of 4. And we've got minus 4P minus 2Q is minus 3. Right, so let's double this one up then. So 6P plus 2Q is 8. Add these two together. 2P is 5. So P is 5 over 2, which means that I've got that Q is 4 minus 15 over 2, which is what, minus 7 over 2. Add them together, you get minus 2 over 2, which is minus 1, which is D. Tall, smooth cylinder contains air at atmospheric pressure of that. Density of the air is that. Heavy piston placed on top of the cylinder. Allowed to fall slowly downwards, compressing the air until the piston rests in equilibrium. Mass of the piston is that. Cross-sectional area is that. What is the density of the air in the cylinder when the piston rests in equilibrium? Right, you assume the air is an ideal gas, right? It's just as well. And the temperature remains constant. So our PV is going to be a constant. That's what we're getting on this for our constant temperature and the ideal gas. So what are we getting then for our change in the pressure? So we've got 50 kilograms. So we've got 500 newtons. And we're dividing that by a 0.02. So that's a 1 over 50. So that is going to equal, well, we're multiplying the top by 50. So 25000. So our new pressure then is, that's one short of reaching that. It's going to be 1 1/4 times 10 to the 5. That's the new pressure. So P is now times 5 over 4, which means our V is going to be times 4 over 5 to keep this a constant, which means our density, mass over volume, is going to be times 5 over 4. So we want to add on 1/4 of this, so 1.5, which is E. Okay, that was a nice bunch all in all. The first section usually pretty quick. They didn't have any particularly sneaky ones in there, I don't think. So I'll be back with the rest of them in the next video.